there, my name is Irene, and in this video, we're going to talk about model-in-place components. We're going to discuss what they are, how they compare with other kinds of geometries that we encounter in Revit, and specifically when and how do we want to use them. So let's get to it. All right, so for this demonstration here, I'm not going to go super deep. We're not going to be talking about how we create model-in-place components or the editing options or whatnot. I just really want to focus on what is a model-in-place component, why do they exist, and how do we use them. So at this point of your Revit journey, you may have already run into the dead end that is the limitations of Revit's existing geometry. So things like walls, floor, ceilings, and even the furniture or lighting fixtures or whatnot that come with Revit, or even those that you download from third parties. Initially, it's super exciting because everything is automated and everything gets generated relatively fast, but you may have already encountered this situation where you're like, the thing that I want doesn't exist, or I want something like this, but I want to change it and I don't know how to, and it doesn't let me and whatnot. So that is where model-in-place components are going to come in. Model-in-place components are basically free-form modeling within Revit. Now, first of all, where are we going to find these model-in-place components? Well, they are going to be under the architectural tab, under components. And in fact, that's where you can also find your family. So you're going to see that components are divided between placing a component. That is what we have been doing up to this point, which is that you select a family and you insert it into your project, and then you have model in place. So the main difference between the families, whether they come from Revit libraries or other libraries in a model-in-place component, is that families are something that you get somewhere else and you insert into your project, while a model-in-place geometry is a geometry that is unique to the one project that you're currently working in because it's created within that project. So a model-in-place component doesn't get saved in your computer. It exists only within the file. Because of this, model-in-place component can be copied in between projects, but there are certain limitations which are going to make a lot more sense once we start modeling and once we see how modeling geometry within a project works. So over time, I have developed this handy cheat sheet that you can currently see on the screen, which helps me really communicate what are the pros and cons of a model-in-place component versus using a family. Again, whether you're sourcing it from the Revit libraries or from third-party providers, in what scenarios we use them, how do they work? So first thing first, model-in-place components exist only within the project that you created them. You can copy them to other projects, but you cannot save them to your computer. While a family is saved to your computer, and then you can insert it into as many projects as you want. Keep in mind, there are limitations to copying and pasting model-in-place components in between projects. Number two, each model-in-place component is unique. So I'm going to demonstrate here. I'm not going to bother explaining the process of creating or modeling with model-in-place components at this point. I'm going to have an entire separate video for that. At this point, I simply want to demonstrate one of the guiding principles of how model-in-place components work. So let's say that I'm just going to create a simple extrusion just so we can see that there is a geometry in model. One of the main differences between a model-in-place component and a loaded component is the relationship between instances. So if you remember, a family has type parameters and instance parameters. And one thing to understand is that all types of a family are related to each other. So they have a common geometry, which is what initially gets inserted. And then when you edit type properties, all instances of that family get edited. Model-in-place components are different. So for example, if this cube would be a family, if I would go into editing the family and then I would save and update the changes, both instances of the family would change because again, the source, the origin is a single file. But in the case of model-in-place components, each instance is unique. So for example, let's say that I'm going to go into the second one here. I'm going to double click to go into editing. There's other ways that we can do this, but here I just want to demonstrate quickly. So let's say that I'm going to edit this guy in one way or another. I could be adding things, I could be changing materials, whatever. When I finish modeling, you can see that this guy hasn't changed, only this guy. So this is important to understand. You do not want to use model-in-place components when the geometry in the model will repeat and has to be consistent design-wise. Anything that repeats in your model should be a family. A third important characteristic of model in place components is that you're going to see that when you work with them, you can assign a category to them. So for example, this generic model here, I generated it. The name is generic model, and I didn't really even bother thinking about what category it is. We're going to talk about that a lot more when we get into creating our own custom families. But for example, if I go here in my project browser and I search for my generic model, let's see where it is. It should be generic model 1. You're going to see that it's simply within families, generic models. So assigning a category in general is important for all geometry, but there are far many more options and more consequences to the selection of that option when we are working with families than when we are working with model in place components. Another important thing to consider when we are working with model in place components is the fact that, and you're going to see this, and it's going to make more sense when we get into the details of modeling within model in place components, but you're going to notice that it feels like the model is locked. What do I mean with this? Well, for example, let's say that with this cube here, I'm going to go to my top view and I'm going to move it. I can move it up, I can move it down, I can move it to the right, I can move it to the left. But now let's see what happens if I switch my view to, let's say, a front view. And I'm going to try to move it up. It doesn't let me. See how it looks like it's locked to the ground? Now, this lock isn't just to the ground. This is something that you're going to see when we start working with model in place components. This is related to something called work planes. We're going to talk about them. We're going to see how they work and why they are important. But in general, you're going to encounter this issue, this limitation, a lot more with model in place components than with families. And this is because in families, you can do certain setups that either lock or release the family to be placed anywhere that you want. So this is another consideration. Model in place components will sometimes have a limited range of movement. So sometimes you cannot copy a model in place component from one project to another. These kind of lock into a work plane. But the same way that there are things that are different between model in place components and loaded components, they also have similarities. So the main one that we're going to see when we get into modeling is that both of them have these free-form modeling that I mentioned a second ago. If I go into edit this guy, you're going to see that you have this new create tab that is completely different. And the only way that you can access it is either by using a model in place component or when you are creating families. So that is something that both of them have in common. Another thing is that both of them are going to contain both type and instance parameters. So we can actually make our model in place components so they are easy to edit. We're going to see how these parameters can be set both with the model in place component and with families later. And then if after all of this, you're still asking yourself, okay, so when am I supposed to use model in place components? When am I supposed to use loaded components? The easiest way to answer this is asking yourself, if you're currently working in a project and you are proposing something, is this something that you are proposing something that is going to be purchased? Or is this something that somebody is going to have to manufacture for you, that somebody's going to have to produce, that somebody's going to have to build, and that they're going to have to build it for this one project in particular? So I want to make this clarification because you could say, well, I'm working in a restaurant project and we are doing these custom chairs and we need 100 of them. Well, in that case, even though the chair is custom, it would be a family because it repeats. So you have these two characteristics. It should be a unique element that belongs just in this one project. If it fulfills those two requirements, then it is a perfect candidate to be a model in place component. So any kind of custom millwork, cabinetry, built-ins, however you prefer to refer to them. So think about things like kitchens, things as vanities, things as closets, things as fireplaces, bookshelves, if you're working with residential design. If you're working with commercial design, you know, the world is your burrito. Things like bars, things like displays, things like architectural details. So for example, imagine that you want to do a wall that is like wobbly. You would not be able to do that with just the wall command necessarily, but you can with model in place component. So this is another important thing to understand. Model in place components, and we're going to see that when we go a little bit more into how we build in the category specifically. Model in place is not a specific category. It's a broad definition. And then within the broad definition of a model in place component, that model in place component could be any category. It could be a wall detail. It could be a floor detail, a ceiling detail. It could be an equipment. It can be any category, right? The other thing that I do want to clarify is that just because you're doing custom builds, that doesn't necessarily mean that you have to engage with model in place components. Personally, I find it easier because then I can be more creative and I can work with more custom sizes and shapes. But I do want to bring up the fact that if you go to the Revit library, and again, other third-party libraries, you're going to see that they do have a whole portion of their library. Oops, I clicked on the wrong place. A whole portion of their library dedicated to the kind of like standard cabinetry that you would use for custom millwork. So the custom of the custom millwork would be how you arrange these standard cabinetry elements. So see, you have like base cabinets, tall cabinets, wall cabinets, even countertops, all of this kind of stuff. So I just want to clarify that just because you are doing cabinetry doesn't necessarily mean that you need to model it from scratch. You can use a little bit of a hybrid where you use some elements from the Revit library and then you model the things that are unique to your design. But in general, model in place is going to be the perfect tool for anything that is uniquely your design. And with that, we have reached the end of this video. As I said, I want to keep this one simple because I just want to introduce to the concept of model in place component, and then future videos will go more into the details of how we set up a model in place component, what are the create tools within the model in place component, what is a work plane, and how we set parameters and whatnot. So if you're interested in this topic, maybe subscribe. That way, when the next video is posted, you will get a notification. If you have any questions, by all means, feel free to add them in the comments. But otherwise, thank you very much for joining in. Thank you very much for sticking through, and I will see you in the next one. Have a good one. Bye.